All right, when we look at this problem, it says how many inches are in 16.3 centimeters? So using our strategy that we're going to kind of look at what we're given. I'm given 16.3 centimeters, and it's asking for, I want inches. Now let me take a minute and sort of notice that this is a length, and this is also a length. So when I'm trying to build my plan, these are the same property, just different units. So I don't need an equation. This is going to be a dimensional analysis. So I'm needing to look for information relating centimeters and inches, which again, it's kind of given to you here. So my plan is I need to start, remember when I do dimensional analysis, we begin with the starting information. Now that I have the plan, the steps for the dimensional analysis is begin with the starting information, which is 16.3 centimeters. And then I'm going to make a conversion factor. And here's my desired units, which is inches. So my conversion factor needs to have the desired units on the top and the starting units on the bottom. And now I can fill this in. So the 1 goes with the inch and the 2.54 goes with the centimeters. And my calculator says this is 6.4173. Because this cancels out and I'm left with inches. Good. Okay, note that when I look, this and this both look like it could be it. The difference is I'm going to need to figure out sig figs. So this one requires me to differentiate, is it 2 or 3 sig figs, or is it 1 decimal place or 2 decimal places? So remember the rule here is because it's multiplication, it's going to go by quantity of sig figs. And let's see. This one has 1, 2, 3, 3 sig figs. This one is an exact. It's an implied exact one. So I'm going to ignore it for sig fig purposes. This has 3 sig figs. Technically, it's also exact, but that may not be obvious. So I see 3 sig figs. So this is going to be my limit. I'm going to round to 1, 2, 3 sig figs. This becomes 6.42 inches. So this would be my answer. All right, let's look at a different question. Convert 155 square feet to square centimeters. All right, this one is going to, I have some information. Again, though, here we go with the same kind of strategy as far as we were starting with. I know that my start or given is 155 feet squared, and my end is that I'm looking for square centimeters, or I could write that as centimeters squared, which might be a little bit easier for me to represent. So this looks like my plan is that these are both, this is area, right? Units squared is area. This is also area. So it's just a change of units. And if it's just a change of units, or if I'm given relational information, I'm thinking dimensional analysis. This is just a proportionality. Okay, so when I do dimensional analysis, again, I start with my starting information, 155 feet squared, and I need to get 2 centimeters squared. So feet squared, and then, I would need to know feet squared and centimeters squared. Note that I have information relating inches and feet and about inches and centimeter, but I don't have anything directly relating between feet and centimeters, or feet squared and centimeters squared. So use the inches as an in-between, as an intermediate. And sometimes I just kind of have to look and sort of say, okay, what do I have? I do know about feet and inches, and I also know about centimeters and inches, so inches becomes a linking factor. So this would be feet squared, inches squared, because I'd still have to stay in some kind of area unit. This would be inches squared and centimeters squared. Note that if I did that, my units work out, right? Feet squares cancels, inches squares cancels, I'm left. So that's looking like a good strategy. All right, now I have to put in my numbers. But here it gets a little tricky. It says units raised to a power. So if 1 foot equals 12 inches, which it does 1 foot squared equal 12 inches squared? So remember, in order to get this to be this, I have to square it. And if I want to get this to this, I also have to square it, which means I need to square both sides of equality. So I have 1 foot squared equals 12 inches, and I'm squaring both sides. So note that when I do this, I get 1 squared foot squared equals 12 squared inches squared. And if I were to do it here, I would see 1 squared inches squared equals 2.54 squared centimeters squared. So I have to square the relationship in order to get a good relationship. So now if I go back and I fill in for my feet squared and inches squared, so for the feet squared it gets the 1 squared. And the inches squared is going to be 12 squared, so I'll put 12 squared here. And then here I'm going to use this information. The inches squared gets 1 squared, and the centimeters squared gets 2.54 squared. And you could square these first, or you could just do it in your calculator. 1 squared is 1, so I'm going to ignore those, but I'm going to do 155 times 12 squared times 2.54 squared equals 143,999 centimeters squared. And when I look, like the only thing that's really close to 1.43 is this. So let's see what would happen if I put this in scientific notation. 1, 2, 3, 4, 5. So that would be 1.439 times 10 to the 5. And if I rounded that, right, I have 1, 2, 3, 1, this is exact. So I should have 3 sig figs and 1.44. So this is the correct answer. Okay, now we get a little bit funkier. 1 200-gram bag of rice costs $8.12. How much does 1 kilogram of rice cost? So I have 200-gram rice. I have $8.12. Sorry, $8.12. I have 1 kilogram rice. So I have rice and money, and it's asking how much does it cost. So my end is cost, which would imply I want dollars. So it looks a little bit tricky. However, look at this. This is really a relationship. I'm kind of saying that these are related. And this, when I see too much information, I'm thinking, is there relationship information? So these are related to each other. So in other words, when we say $8.12, that's the 200 grams equals or is $8.12. So this is the mass and dollar and cost relationship, let's say. So we're kind of relating that. So because of that, for my plan, I'm seeing, although they're not the same units, but I don't have an equation relating, and it did give me problem gave relationship. So I'm thinking that this is dimensional analysis. Which means once I've decided it's direct dimensional analysis, I'm going to use this as a conversion factor. So this is 200 grams rice is $8.12, or I could put the $8.12 on the top and the 200 grams of rice on the bottom. So given that, note that this by default, because this was by itself, so that's going to be my starting unit. Okay, let's solve the problem in blue. So remember, we start with 1 kilogram of rice. So I want kilogram of rice on the bottom. Can I go directly to dollar? Do I have information about kilograms and dollars? Look, this is grams and dollars, right? And this is kilograms. So I'm going to need to use grams of rice as a linker. And then grams of rice and dollars. Dollars is where it goes in front. And I would be left with dollars, which is what I want, right? So this would be the kilograms of rice would cancel out, the grams of rice would cancel out, and I'd be left with dollars. All right, now I can fill it in. Okay, grams and kilograms, I need a relationship. Well, if I go look up my metric prefixes, I look up that kilo is 10 to the 3. So 1 kilogram of rice is 10 to the 3 grams of rice. And then I see here I can use this information. I want one with the grams of rice on the bottom. So 200 grams of rice, $8.12. And now I can multiply it through. 1 times 10 to the 3 times 8.12 divided by 200 is 40.6. Now, sig figs, this is kind of an ugly problem, realistically, because this is technically the way it's written. This is really 1 sig fig, and this is 3 sig figs, and this is really 1 sig fig, so it's a sloppy problem, sig fig wise. So it really would be, I'd have to round it to 1 sig fig, $40 with 1 sig fig. So it's a little sloppy there, but this is really about more building strategy than it is about sig figs. Children can be given 10 milligrams of Motrin per kilogram of body weight up to 4 times per day. If liquid Motrin contains 100 milligrams per 5 milliliters, how many milliliters should you give to a 42-pound child per time? So, wow, there's a lot of information. Let's sort through it. Okay, I'm given 10 milligrams of Motrin. But look, I see this linker per. I am always suspicious. Like, this is linking this to this. So, I'm going to keep this together because it is relationship information per 1 kilogram of body. And then 4 times per 1 day. And then liquid Motrin contains 100 milligrams. Let's see, this is 4 times per day. This is linking that. 100 milligrams per 5 milligrams, that's linking that. 5 milliliters. And then it's asking me, end is how many milliliters? So I want volume. And I also know 42-pound child. Okay, so as far as my plan goes, I see 3 related pairs of units. This is hinting that this is going to be dimensional analysis. Okay, so note that again, when I have related pairs, I'm going to kind of sort of see what this is. So this is a mass, right? And then this is milligrams, this is mass, and this is mass. Wait a minute. How can 10 milligrams be equal to 1 kilogram? I have to be really careful here. I have different kinds of masses. Notice this is talking about the mass of the medicine. And this is talking about the mass of the body, of the patient. So I have 2 kinds of masses. So I need to be careful in every instance. What are we looking for? So 4 times per day, this has nothing to do with mass, but this is mass. And so this is mass. And when I reread, I go back to here and I'm like, liquid Motrin contains 10 milligrams. So this is mass of Motrin or medicine. And then this must be per 5 milliliters of medicine. And then when I'm looking, how many milliliters, it wants to know milliliters of medicine. Okay, once again, this is kind of the thing by itself. So I'm going to start with that. Let's go to blue. 42-pound. I'm going to just say, I'll say body, or because I want to be consistent. Here I'm calling it a child. Here I'm calling it a body. And so I want pounds of body. And then I want to see so I have, and I can kind of build a strategy. So if I'm going from pounds of body, I have mass of medicine, I have the mass of the patient, so it looks like I want to go from pounds of body to mass of the Motrin, and then to volume of the Motrin. So this one's relating the body and the mass of the medicine, right? So the mass, except for it's in kilograms. So I need to go from pounds of body to kilograms of body to mass of Motrin. And I can kind of write these out. So this is 10 milligrams of Motrin. It may help me to sort of see my units. 1 kilogram body. This is 4 times per day, 1 day. This is 100 milligrams of Motrin per 5 milliliters of Motrin. And okay, so I'm looking for, again, pounds of body. I'm recognizing I have to go to kilograms of body because all these mass units are in metric. But if I had kilograms of body, then I've got this one, right? This one has kilograms of body. I kind of highlight. Right? So I could use that one there. So that would get me, so that's hinting that on the top I'd want to go to milligrams of Motrin. And now once I have that, right, then I'm going to put milligrams of Motrin on the bottom. And I'm looking for, okay, I already would have used this one. So now I'm going to go for, oh, but wait, I have milligrams of Motrin here, right? So, but I'm going to flip that. Okay, that's okay. So I will go from milligrams of Motrin, whoops, I want a pen. Milligrams of Motrin to milliliters of Motrin, which is good because that's what I'm trying to get. Okay, I'm kind of building my strategy. I'm ready for my numbers. I can fill in this one, 10 milligrams of Motrin per 1 kilogram of body, and 100 milligrams of Motrin. I want to match it, make sure and put it in the right place with the Motrin, and 5 milliliters of Motrin. I just need this. So I go looking on my, looking up on my reference sheet, and I see that 1 pound is 2.2046 kilograms. Sorry, I did it wrong. I looked it up wrong. I had the numbers reversed. So it's 1 kilogram is 2.2046 pounds. And that's why I double checked, because it's really easy to make those errors. So pounds of body will cancel, kilograms of body will cancel, milligrams of Motrin will cancel. I'll be left with milliliters of Motrin. All right, now it's just a matter of going through 42. I could skip the times 1 or plug it in, it's fine. 2.2046 times 10, divide by 1, times 5, divide by 100. And I get 9.5255 milliliters. Note that really there's some sig figs. This is a little bit loose. This is exact. This is exact. We would say that these are an implied per kilogram. When it's an implied one, that's an exact one. But this is only 1 sig fig. This is also a sloppy sig fig problem. Because this is only 1 sig fig. This is 2 sig figs. This is either 5 or exact 5 sig figs. This is 1 sig fig. So realistically, this would be 1 sig fig. I would, okay, if I'm using chemistry rules, I'm going to round that to 10 with no dot milliliters Motrin. However, of course, generally in medicine, we always round down. So we would give 9. But again, we can just use chemistry problems, chemistry rules in this class. We're not actually going to execute it. All right, last problem. How many Zumquats are there in 14.2 glips of Zenol? There are 35.7 glips per gander of Zenol. There are 1.35 times 10 to the 14 Zumquats in every gander. Whoa. Okay, I can see the end point is I need Zumquats. All right, what am I given? Okay, I'm given 14.2 glips of Zenol. And, right, so I got that. 35.7 glips. Oh, this is that per again, right? So I'm going to relate that. 35.7 glips per 1 implied gander. And there are 135 10 to the 14 Zumquats. But I have to go back. In every, this is also kind of a relating. It's saying like in one, so 1 gander is equal to this. It is relating. So I can think of this as being like this is equal and this is equal. So I have in my hints 2 relationships of units. So here I have glips and gander. And here I have Zumquats and gander. And this is by itself. So this would be glips. Note that I have glips And then this relates glyphs and gander, so I can go from glyphs to gander to kumquats, because this one relates gander and kumquats. So I have all the information. This is dimensional analysis. Again, it may not be, I'm looking for clues, but I'm thinking this is dimensional analysis. I have a plan. I spelled that wrong. All right. So we begin with the thing that is not a relationship. The 14.2 glyphs is by itself. I'm going to ignore the xenol because really the xenol is giving me additional information. 14.2 glyphs. So I have glyphs on the bottom. I'm going to go to gander. Then we go from gander to kumquats. And then I would be left with kumquats, which is what I want. Okay, now I can fill in the information. So glyphs and gander. One gander, 35.7 glyphs. And one gander is 1.35 times 10 to the 14 kumquats. Glyphs canceled, gander gets canceled. Let's see, 14.2 divided by 35.7 times 1.35 e to the 14 divided by 1, 45.36974 times 10 to the 13. Okay, now we round. This is 3 sig figs. This is all multiplication, so I'm going by quantity. This is an implied exact. The ones are per, right? We added in the one. So, and then this is 3 sig figs, and this is 3 sig figs. Remember, multipliers are exact. So I have 3, 3, 3. Guess what? 1, 2, 3. So this will be 5.37 times 10 to the 13 kumquats. Hopefully you've sort of seen some sort of how do we sort of look at what we have, look at what we need, decide, is this a conversion, is this a dimensional analysis, is this an equation, look for some clues, get a plan together, and then execute.